Hello. We're about to finish this thing up, all right? We've got one more challenge in our algorithm challenge here, all right, for this free code camp thing. I'm looking at it. It's called Pairwise right now. Luckily, it's pretty simple. There is only one sort of catch here that logistically that we have to go over. If you take a look at the problem itself, let me share my screen. We'll show you what I'm talking about. What we have here is we need to figure out what things add up to, let's say, 7. So they're going to pass us an array and another argument and an argument, all right, that they're passing in. We have to add the values of things of this array together. For example, 4 and 3 equals 7. So then we have to add their indices together. This is index 1, 2, and 3. That'll be, so that equals 4, right? But that's not what we want to return, right? Somehow we should return 11. Why is that? Well, also, this index and this index equals 7 as well. And we don't want to reuse this 4 and 3, but we still want to keep this 4 and 3 position here. So this is sort of where we're going to get hung up, or we could get hung up. So the index of 2 and 5, so that's 0, 1, 2, right? 3, 4, 5. So 2 plus 5 is 7, plus the 4 from the other indices that we added up, we should return 11. Notice that the positions cannot shift in this array, but we don't want to count these numbers more than once, all right, or these values more than once that we're using the indices of, okay, to add up. So this one there is going to be 4 total indices that we're using to add together, and each one of those we're only going to use once, which means we need to transform some of these values or set them equal to something that's not a number, and it could be anything. But we're just going to use not a number because it just has to be not a number. I mean, I'm assuming you could probably use anything else, but we'll just go with not a number for now. This was really the point that got me hung up, and that was the one piece that I really had to do a little bit of research on to figure out. Right away, we know we're going to be using a prototype reduce. Reduce we've used a bunch of times before. Here are the parameters. Okay, and so the parameters that we can have in reduce, remember, is the accumulator, which is the value we start adding to. All right, we also have the current value or the next value. We also have the index that we can access, or the current index, and we have the array, all right, which so we can call things like array.length, which is what we need. So this is pretty much just as simple as it sounds. So all we have to do is we're just going to return this arr.reduce. Okay. And that's pretty much the entire challenge, except there are going to be a few things that we're going to have to remember here. So we're going to be using reduce, but we have to make sure we're using it correctly. So we're going to pass an anonymous function here, and we need to make sure that we have all of our parameters in here. So the parameters themselves are the things that we're looking for. The arguments are the specific values. But the parameters we're going to be using, all right, is the accumulator, all right, the current value, all right. I actually like that being called next. It kind of helps me see like what we're actually doing, because it's the next value, all right, not what's already there been added, but what's coming next, or what is next. The index and the array, all right. And notice that this ARR is already taken here for array, so I just spelled out array there. So accumulator, next, and array. All right, that's what we're looking for here. Those are our parameters that we want to pass into our function. All right. Also, now the accumulator itself, I don't want to start with just this number 1 here, or the value here. What I want to start with is 0, because I want to add the indices, all right, to the accumulator. All right, so I want the accumulator is going to be what is going to be taken out of this. Remember, it reduces down to just the accumulator. So I just want to be adding the indices to that accumulator. I don't want to add the value, so I want to make sure I have a starting value of 0 in my accumulator. Therefore, the next value, all right, is then going to be 1, because it's starting at 0. All right, that's why I like next. It just kind of, I just like the way that was said by somebody else. I thought that was really, really good. And since we're going to go through and we're going to iterate through this here, trying to figure out what equals 7, or this arg, sounds like we're going to be iterating through every one, right? Therefore, it's going to be a for loop, right? It's just a standard for loop. your var I equals, we could say 0, but I really don't want to start at that 0. What I want to start with is this index +1 here, right? So wherever our starting index is 0, I really want to start identifying this and kind of work our way through to the end here, because I'm really looking at adding these indices together. So that's how come I want to start with var I equals 0. So that way I can access the sort of the ARR, right? So the ARR itself of that index, okay, the index of where we are, and the index +1, which I'm going to call I. So index +1, okay? Hopefully that makes sense to you. So since I need to add these two numbers, the current, or this next value, plus the index +1, which is the next to the next, all right? All right, so here we go. Also, how long do I want to do this for? Well, only the length of the array, right? So I just want to go through and say that as long as I is less than array length. And again, this is pretty simple. I++. We've done this, seems like 100 times already. All right, so we're inside of a for loop now. Now we're in this for loop and we're iterating through this for loop. All right, now reduce is going to start here. This for loop is really just looping through, looking for these next to next values, right? So if it starts at 0, then the next value I'm going to evaluate is 1, but I also want to be able to access this one. Now I could just say index +1 or I +1 to access that, or I could set it up as index +1 right in my for loop to get a fewer number of cycles there. I think this way works pretty good. Either way works. Then all I have to do is say, well, if these two numbers here, all right, if these two numbers here equal 7, good. That's it, right? But if they don't, let's just add another one and look at 1 plus 4. Do they equal 7? No. 1 plus 2 then. Does that equal 7? No. All right. Remember, we're add 1 through this for loop. Then it's going to go to 3. 1 plus 3. Does that equal 7? No. 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 Okay, that doesn't work. Now reduce is going to go to the next value, this 4. All right. So then 4. 4 plus 1, well, we don't have to calculate that. And we're starting at var I index +1. So we're going to be 4 plus 2. Does that equal 7? No. 4 plus 3. Does that equal 7? Yes, it does. All right, now we found a successful value. Now we have to do something. And so that is going to be how the reduce is going to work in conjunction with this for loop. So if, all right, the array, notice that I can call this array, luckily. So array of the index itself, which is the value that we're on. All right, so if the array at this index of itself, all right, which is going to access the value. So if that value plus array plus this ith value, right, which is nothing more than the next one over, all right, or possibly the next one over, or possibly the next one over, or possibly the next one over. Remember our for loop. So as long as it finds one of these that equals something, well, it's got to equal 7 in this case, and 7 happens to be arg. So this value needs to evaluate to true. So if it equals, and again, good practice is making it exactly equals. So there we go. If that equals the argument, so if that is true, all right, I can add something to the accumulator, right? So the accumulator plus equals, now what does it equal? Now, we don't want to take the value, okay? We don't want to take the actual value. I want to take the index number. And what's cool is that the index number, all right, is the just index. But I also want to take the index number of wherever I am in this for loop, right? Because that means it already equals that 7. And luckily, I already have that. So, and that's called I. And that's just the index number. That's not the value. So my accumulator is only counting index numbers. Now, this is the tricky part, all right? This is the tricky part. As we're going through this, all right, if we say this is good, this for loop is going to keep counting through, all right, and not find anything. So it'd be 4, then 2, then 3. Oh, look, we found something. And then it's going to keep that 4 and keep counting see if 4 plus 0 or 4 plus 5. So this 4 can get reused. Then on the next cycle for reduce, it's going to start with 2, then say, well, does 2 plus 3, so on and so forth, right? And then eventually it's going to look to this 3. But I want to make sure these 4 and 3s disappear so we only use it once. Now, if I delete those values, okay, if I delete those values, then it's going to change all of these index numbers. I don't want it to change the index numbers, but I need a placeholder. So I'm just going to make them something else. So I'm just going to assign both of these values to not a number. And so a shortcut for this is just array, okay? And then we're going to use the index. I'm going to make sure that that is the same thing. Remember, single values is going to assign array I, and that's going to equal not a number, right? So it's going to set array sub I to not a number, and since that's not a number, it's going to set array index to also to this, which is now not a number. So they're all going to be not a number. So as we're going through then, through this first iteration, this first success, this 4 is going to show up as not a number, all right? And this 3 is going to show up as not a number. Okay, so that's that one success. Not a number, not a number still have index values, which is important. It doesn't change anything. Then reduce is going to go over to 2. Is 2 plus not a number 7? No. 2 plus 0 not a number? Or 2 plus 0 7? No. 2 plus 5 a number? Oh, yes, it is. So then it's going to add the index values of those to our accumulator and then transform these also to not a number. This is what our array will look like at the end of this cycle here. See that? And we didn't mess with the indices at all, and they're still there. One thing we have to remember to do to break out of these for loops, okay, or not out of the for loops, rather, out of the reduce, is we have to remember to return out of this reduce, okay? So if you remember, as we go back through here, one of the things we have to make sure we do, and we go through in our documentation here, is return out of our reduce method. So what are we going to return? Well, we're just going to return the accumulator, right? And that's it. So we can run this. All right, one loop to rule them all. And that's it. All right. It's pretty simple. The hardest thing is making sure we don't change these index numbers, which is what this right here does. Transforms them to not a number. And that really took me the most time. Everything else seemed pretty simple, except I kept breaking out of the loop early, which I'm sure is the same problem you've had. Well, again, hopefully this was helpful, and I'll see you all next time.